Hi student, we're going to start the first chapter by continuity and derivability. Our definition of a limit. A limit exists if limit to the right must be equal limit to the left. So always if you have a function, the limit exists at a point if limit to the right equal limit to the left. Even if you have void, here we can say that limit exists because as x tends to a minus or x tends from a plus, the limit exists and will come near f of a. Even if it's a void, limit exists. But however, it will be continuous if limit to the left equal limit to the right equal f of the point. So here it must be filled. So always when you have continuity, as long as you are graphing, you cannot have any void or any jump. So always limit exists when it is direct. We don't have any void. So limit exists if limit to the left equal limit to the right equal f of a. So here we can say in this picture here that limit exists but not continuous, because why? We have void. So here we know that limit as x tends to c plus from that side or from that side or from that side, the limit is L. But however, since f of c does not exist, it's void, so we say a limit exists here, for example, but not continuous. And here the same, f of a does not exist, it's something else, it's a point m. However, limit to the left must be equal limit to the right equal f of the point. So here, since it's void, so limit exists but not continuous. So to be continuous, always all the points must be filled and direct. Basic limits, we all know infinity plus infinity is infinity, minus infinity is minus infinity, a number over 0 plus or minus infinity, a number over infinity 0, you know it from before, 0 over infinity 0, infinity over 0 is a plus or minus infinity. Why 0 over infinity 0? Because can be written as 0 times 1 over infinity, and a number over infinity 0, so 0 times 0, 0. Here this can be written as infinity times 1 over 0, a number over 0 plus or minus infinity times infinity, it's a plus or minus infinity. However, if you have 0 over 0, we used to put before in factor, common factor, or we can use what's called Hospital's rule. When we're going to start the limits, I will introduce Hospital's rule. Similarly, for infinity over infinity, we can apply Hospital's rule. And similarly, 0 times infinity, we can apply also Hospital's rule. So 0 over 0, infinity over infinity, 0 times infinity are undefined. We need to apply Hospital's rule to get the answer. And if you have infinity minus infinity, one of the ways we can use it is put in factor, because infinity minus infinity is unknown. So that's why we put in factors. The only limits that we know are these. We can predict we know the answer of it. But for 0 over 0, infinity over infinity, 0 times infinity, the preferable to use Hospital's rule. Infinity minus infinity, we put in factor. So we know that concerning limit unit from last year, if limit as of f of x is L, g of x is m as x tends to c, limit of a sum is L plus m, you add the limit. For subtraction, it will be L minus m. If you have times k, you can put k outside, so it will be kl. If you have a product, it's lm. If you have it over, it will be L over m, where m is not 0. If you have a power, it will be L power n. And if you have nth root, it will be L power 1 over n. So these are very easy. You already are familiar with these, even without knowing them, that they are properties. Let us do some limits. Limit as x tends to 3, you replace x by 3, very simple. Limit here as x tends to 3, it will be 6 minus 5 is 1 over 9 minus 4, 5. I don't have anything not clear here, it's very simple. Limit as x tends to 1, it's 0 over minus 3. 0 over minus 3 is 0. Limit as x tends to 2, it is 1 over 0. But I don't know if it's 0 plus or 0 minus, so we say a plus or minus infinity. Limit as x tends to 3, it's minus 2 over 0. Come in, I don't know if it's 0 plus or 0 minus. So plus or minus infinity. However, if I have limit as x tends to 3 plus, always use the plus and minus when you have a number over 0. So here you have minus 2. 3 plus, I have 0 already down, but if 3 plus, as if you have a 3 point something. 2 times the 3 point something, it's 6 point something. Minus 6, it's 0 plus, and it's 0 0.00, etc. mini 0. So minus over plus is minus infinity. And if you have 3 minus, it will be as if you have 2.9. So 2.9 times 2, and 5 point, for example, 8 or 5.999 minus 6, it is negative, minus 0.000. So minus over minus is plus infinity. You took this last year. Limit as x tends to 2, similarly, it is minus 3 over 0. We don't know if 0 plus or minus infinity. If you have it 2 plus, bigger than 2, so here it will be bigger than 4 by epsilon. So it will be minus 3 over 0 plus minus infinity. Here, if you have a 2 minus, it's 1.999. Square it, it will be, for example, 3.999 minus 4, it is 0 minus. Minus over minus positive. Limit as x tends to 2. Here you have 0 over 0. You put in factor as you know. But from now and on, if you have 0 over 0, you can apply Hospital's rule. What does Hospital's rule say? We write limit. Using Hospital's rule, we write HR. It will be the same as limit as x tends to 2, derivative up over derivative down. Derivative up is 2 over derivative down is 5, so the answer will be 2 over 5. We don't do the derivative as u over v. We do u prime v minus v prime u over v square. You do derivative up over derivative down, so it's f prime of x over g prime of x. We use this one only when we have 0 over 0, infinity over infinity, or 0 times infinity. Like here, limit as x tends to 1, 0 over 0, you have x minus 1 in factor. We used to do it last year, factorized. From now and on, you can apply Hospital's rule. We write, since limit is 0 over 0, we can apply Hospital's rule. So it's limit as x tends to 1. We do derivative up for x over derivative down 5, replace x by 1, you're going to get 4 over 5. Here, limit as x tends to 3, same story, 0 over 0. Either you factorize or we apply Hospital's rule. So we say it's limit as x tends to 3. So we do the derivative up. It's 2x over 2x minus 6. Replace by 3, you're going to get 6 over 0. A number over 0 is a plus or minus infinity. And if you do here limit as x tends to 3, for example here, come in, it is 0 over 0 because 9 times 18, 18 minus 18, 0, and 9, and minus 9 is 0. So we use Hospital's rule. So it will be 4x minus 5, derivative over 2x minus 1, replace x by 3, 12 minus 5 is 7, and 6 minus 1 is 5. So directly Hospital's rule will enable us to find the derivative, the limit, in a very easy way. Here, limit as x tends to 0, as you can see, it is 0 over 0 because 0 over 5 minus 5. So instead of doing this whole process, multiply by the conjugate, you can do Hospital's rule. It will be 2. You put HR and you put limit as x tends to 0, certainly, over derivative of radical u is minus, you have minus here, u prime 1 over 2 radical u, 25 plus x. So the answer will be 2 minus 2 into or minus 4 square root 25 plus x, and replace x by 0, you're going to get minus 20, the same one as you have it here. And the last one, here you have 0 over 0 if you replace x by 3. We do Hospital's rule. This is 2 radical 2x. Derivative is u prime over 2 radical u. So this is 2 over 2 radical 2x, and you have this 2 up. Over derivative of 2x minus 6 is 2. So this is 4 over 4 radical 2x. 4 and 4 cancel out. Replace x by 3. You're going to get 1 over radical 6. So Hospital's rule, always when you have 0 over 0, infinity over infinity, or 0 times infinity, you use it.